Welcome to our countdown of the top 10 scientific discoveries that changed our understanding of climate. In this video, we will explore groundbreaking revelations that have shaped the way we perceive the complexities of our planet's climate system. From the historic insights of the greenhouse effect to the alarming realities of ozone layer depletion, each discovery reveals a critical piece of the puzzle. Join us as we delve into the science behind climate change and what it means for our future. Let's get started. 1. The greenhouse effect. A 19th-century revelation. In the 1820s, a groundbreaking revelation emerged when Joseph Fourier proposed a theory that would later be known as the greenhouse effect. Fourier suggested that the Earth's atmosphere functions much like a greenhouse, trapping heat and warming the planet. This discovery was pivotal, as it laid the foundation for our modern understanding of how gases like carbon dioxide, CO2, play a crucial role in regulating global temperatures. Without this seminal work, the intricate dance of Earth's climate might have remained a mystery for much longer. The simplicity of Fourier's analogy helped scientists and the general public alike grasp the concept of atmospheric heat retention. His work was not just a scientific milestone but also an early warning about the potential implications of human activities on our climate. 2. Carbon dioxide's role in climate change. The Keeling curve. Fast forward to the 1950s, when Charles Keeling embarked on a mission to measure atmospheric carbon dioxide levels at the Mauna Loa Observatory in Hawaii. The result was the famous Keeling curve, which vividly depicted the steady rise of CO2 in the atmosphere. This discovery was monumental as it provided concrete evidence of human impact on the atmosphere and its direct link to climate change. Before Keeling's meticulous work, the idea that human activities could significantly alter atmospheric composition was largely theoretical. His findings transformed climate science, leading to a greater awareness of the need to monitor and reduce emissions. The Keeling curve remains a powerful symbol of the human fingerprint on our planet's climate. 3. Milankovitch cycles. Unveiling Earth's climatic dance. In the 20th century, Serbian scientist Milutin Milankovitch introduced a theory that explained the influence of Earth's orbital variations on climatic patterns. Known as the Milankovitch cycles, this theory detailed how changes in Earth's orbit and axial tilt could trigger shifts in climate over thousands of years. This discovery was instrumental in understanding natural climate variability and explaining the cyclical nature of ice ages. By revealing the natural rhythms of Earth's climate, Milankovitch's work provided a crucial context for distinguishing between natural and human-induced climate changes. It highlighted the intricate interplay of celestial mechanics and terrestrial climate, underscoring the complexity of our planet's climate system. 4. Ozone layer depletion. A global wake-up call. The 1970s and 1980s witnessed a startling discovery: the depletion of the ozone layer caused by chlorofluorocarbons, CFCs. Scientists found that these man-made chemicals were causing a significant reduction in the ozone layer, leading to the formation of the infamous Antarctic ozone hole. This revelation was a global wake-up call, prompting swift international action through the Montreal Protocol to phase out CFCs. The impact of this discovery extended beyond ozone protection, as it demonstrated the power of coordinated global efforts to address environmental challenges. The success of the Montreal Protocol became a blueprint for future environmental agreements, showcasing the potential for international collaboration in mitigating climate threats. 5. Global warming projections. A glimpse into the future. In the 1970s, early climate models began projecting the potential impacts of increasing greenhouse gas concentrations on global temperatures. These models suggested that continued fossil fuel consumption could lead to significant global warming. This discovery was a turning point, as it provided a glimpse into the future and highlighted the potential long-term consequences of unchecked emissions. The projections from these early models served as a catalyst for further research and policy discussions on climate change. They underscored the importance of understanding and mitigating the impacts of human activities on the climate, setting the stage for the development of more sophisticated climate models in subsequent decades. 6. Anthropogenic climate change. The 1990s consensus The 1990s marked a pivotal moment in climate science with the publication of the Intergovernmental Panel on Climate Change, IPCC, reports. These reports provided compelling evidence that human activities, particularly the burning of fossil fuels, were the primary drivers of recent climate change. This discovery strengthened the scientific consensus on human-caused global warming and informed international climate policies. The IPCC's work was instrumental in raising awareness and understanding of the human impact on the climate. It served as a foundation for global climate negotiations and agreements, emphasizing the urgent need for coordinated action to mitigate climate change. 7. Ocean heat content. The hidden heat sink. In the 2000s, researchers began to unravel the critical role of the oceans in regulating Earth's climate. Studies showed that the oceans absorb most of the excess heat generated by greenhouse gas emissions, leading to rising ocean temperatures. This discovery highlighted the oceans as a hidden heat sink, playing a vital role in buffering the impacts of climate change. Understanding ocean heat content became essential for predicting future climate scenarios and assessing the risks associated with oceanic changes. The realization of the ocean's role underscored the interconnectedness of Earth's systems and the need for comprehensive approaches to studying and addressing climate change. 8. Cryosphere changes. Melting giants. The advent of satellite technology in the 2000s unveiled a stark reality: the rapid melting of glaciers and ice sheets in Greenland and Antarctica. This discovery provided tangible evidence of the direct impacts of global warming on polar regions and the implications for sea level rise. The cryosphere's response to climate change became a focal point for researchers, as it offered a visible and measurable indicator of climate shifts. The melting of these frozen giants raised concerns about the long-term consequences for coastal communities and ecosystems. It emphasized the urgency of addressing climate change to preserve the delicate balance of the cryosphere. 9. Climate feedback mechanisms. The amplifiers of change. Ongoing research into climate feedback mechanisms has shed light on the complex interactions within Earth's climate system. Feedback loops, such as the albedo effect and permafrost thaw, demonstrate how small changes can amplify warming. This discovery has enhanced our understanding of the potential acceleration of climate change and the challenges of predicting its impacts. The study of feedback mechanisms has revealed the intricate web of interactions that can either stabilize or destabilize the climate. It has underscored the need for comprehensive climate models that account for these feedbacks to accurately forecast future climate scenarios. 10. Extreme weather attribution. Linking events to climate change. Advances in climate science in the 2010s have enabled scientists to attribute specific extreme weather events to climate change with a high degree of confidence. This discovery has provided clear links between human-induced climate change and the increased frequency and severity of extreme weather events. The ability to attribute events such as hurricanes, heat waves, and floods to climate change has significant implications for risk assessment and adaptation strategies. It has underscored the urgency of addressing climate change to mitigate the impacts of extreme weather on communities and ecosystems. The attribution of extreme events has become a powerful tool for communicating the real-world consequences of climate change to policymakers and the public.